Hey everyone, this is Matt Perez, and welcome to episode 11 in our ScanTo3D part design series. So we just have a few more things to handle on this part before we can button it up and save it. The first thing we need to do is create a relief in the top of this part so that the entire middle section of this plastic can flex as we're inserting the camera. So we know that we want this piece to help retain the camera so it doesn't pop back out, but we need to make sure that we have enough flex in this area that it can actually move out of the way as needed. So what I want to do is just simply do an extrude cut on this top section, but I need to figure out where we need to cut it. So there's a few ways that we can do this. We can use some of these planes from our inserted part. So if we go down to our camera inserted part, we take a look at our planes. The front plane is probably going to be the best bet for us. So we're going to use the front plane, start a new sketch, and before I start a new sketch, I'm going to use convert entities, intersection curve, and just grab some of these outside surfaces and some of these inside surfaces. What this is going to do is it's going to bring the geometry that's near that front plane into my sketch. So now I know what I'm working with. So if I take a look at this in a normal 2 view, we now have the sketch geometry for the outside shape. We have the sketch geometry for the inside bore. So what we want to do is, again, we want to make a cutaway from some of this upper material here to allow it to flex out of the way. So again, I'm going to use convert entities. I'm going to grab the 2 edges of this part that we're using to actually snap into place. And then I'm simply going to draw some straight lines that are tangent with that geometry. And then we want to just create some lines that are parallel to those. So we could use the offset option, or we can simply sketch them, make them parallel, and then give them some sort of dimension. Now in this case, I'm going to make them 0.04 apart. I'm going to give it plenty of material removal to make sure that this thing flexes. I'm just going to finish off the ends of these. Make sure that these 2 are collinear. Now really where these end doesn't matter, but you do want to make sure that you finish off the sketch. And then we need to add some lines on the inside here as well. So again, where these end up doesn't really matter as long as you finish them off inside of the main bore. I'm going to turn this into construction and all of my outside geometry into construction as well. I really just want it in the sketch so it gives me a good idea where we're working on this stuff with. Alright, so now if we rotate this around, you can see we have the 2 cuts. So go ahead and exit the sketch and do an extrude cut. I want to make sure that I go past the area where the snap is to make sure that I have enough information. So I'm going to use my offset from surface option, and I'm going to say I want it to be 1/4 inch back. Now you can see that leaves a bit of material, and it's actually pretty close to where that snap is, so that it's not going to give us enough flex. So let's do a 625 and see how much that leaves us. So I think that will allow it to flex enough, but still give us enough structure. So now that we have those 2 relief cuts, I'm going to go back and I'm going to add a fillet on the front section of this part. I'm going to make it fairly large so that it blends in, gives us a little bit more strength in this area. Alright, let's go ahead and put the camera body back in and take a look at a section view. Alright, so we still have the small bump in this area, and that allows us to interact with the camera. It's actually going to hold the camera and keep it from ejecting, and then we have these cutouts here that allow it to flex. So obviously we would need to do some testing. There would need to be a little bit of work to make sure that that works. Now I can already see that I want to come back in and I want to do an offset from that original plane, and I want to make it a little bit smaller cutout. I don't want it to flex nearly as much because we don't want this thing to be able to pop out on its own either. Alright, so I think that's a much better option. That'll still give us enough flex and allow this part to go in. Now we do also want to add some fillets in here as well. we want to make sure that we grab all four of these vertical corners. and we're going to have to put in a fairly small fillet. But that way we don't have any stress risers because we are allowing this area to flex. We don't want to have the 3D printed part break in this area. Alright, so now that we've handled that, we need to make sure that we have enough room, enough movement for the cable. So let's go back, turn on our cable body, how it exits, and take a look at a section view. I'm going to do a slight offset here. And you can see that the cable exits the center back of our camera, and it's an 1/8 inch diameter. So we need to make sure that we have enough room for the cable, and we want it to exit all the way to the back of the surface. So several different options here. We could do a sweep, or we could come back and, as I mentioned before, we could shell out a certain area of this part. Because you are 3D printing this, you do have the available option to shell the entire thing as long as there's some sort of exit for the material. Now, if you're using an SLS operation where it's essentially a big vat of powder and that powder gets cured, if we create a closed chamber, there will be powder in there. So you can still create these closed chambers as long as there's some sort of small exit for that material. So let's go ahead and save this part, and let's take a look at just shelling it. So I want to select this solid body and do a shell operation. And let's say that we want to do 0.08, and we'll say OK. So the thickness value is greater than the minimum radius of curvature. We're going to go ahead and say OK and see what happens. Let's do a section view and take a look at what happened. So you can see we're getting some sort of issue, some sort of error here, and that's telling me that the shell did not succeed how we intended it. It's still a solid body, and that's okay. It doesn't always work out that way, so we'll go ahead and we'll delete that shell operation, and we'll go ahead and modify this manually. So we know where the back of the camera is. So if we hide this, we know where the back of the camera body is. We know that cable doesn't necessarily have to come out straight. There might be some small strain relief here. Now, the good thing that we have here is we really don't need to make the hole for the cable that small. All we need is a small lip to ensure that the back of the camera is actually lining up where we need it to. So I'm going to start a sketch on this back face, and I'm going to draw a circle, and I'm going to make that circle just a little bit smaller. I'm going to say 0.25. That way we have a small flat face on the back side of the camera, but plenty of room for a cable and a connector. And now that we have this, let's go ahead and turn our solid body back on for that fillet. But what I want to do is actually make it transparent. So I want to be able to see inside there. Now this is not a flat face back here, but what we can do is create a 3D sketch and start a spline at the center of that cable, and then just bring it back in space. Now you'll notice that it's drawing it in the XY plane currently. If I hit the tab key, it'll allow me to pick a different plane, in this case the YZ plane, which is where I want it. So what I want to do is make sure that as it exits this face here, I'm going to make sure that I select other, that the end of the spline is normal to that face. So I want to select the back face of our camera using my select other option, and then select the handle, make sure that that's normal too. In some cases you might have to hide some of this geometry. It makes the selection process a little bit more difficult. Alright, so what we can do is we can take the spline handle, and we want to make sure that it's along an axis. Now in this case we're going to say along Z, and that'll align it where we need to. And then we can rotate this thing around, and we can make sure that it exits the body where we need to. Now again, we don't really have to make any use of manufacturing processes. It can print this geometry no problem. So now we can do a sweep cut, grab this geometry, and then sweep along this path. And we want to make sure that on our feature scope that we're only removing it from this solid body here. So now if we go back up and we make sure that it's not transparent anymore, we can see that we have plenty of room for the cable as is, and we can also push a connector through there. Now again, because this is 3D printed, we don't have to worry so much about that information. The last thing I want to do here is add a fillet to this edge. So I want to make sure that it goes all the way around the part. Now even though we have tangent propagation turned on, a lot of times you'll have to manually go around and select some of that geometry. And let's make this a little bit bigger. Let's see how big it'll let it go. Let's see if we'll go up to 0.08. So that way we were able to smooth it out a little bit, and get a little bit better idea of the interaction between this surface and the original surface that it's laying in. So you can see, even though it's not the most aesthetically pleasing, it's going to fit the pocket perfectly. It's going to allow that camera to go through, and we've got the cable exit back here that allows us to push the entire cable through. So the last thing we really need to talk about here is saving this out and saving some settings. We can do a bunch of little detail work as needed. We can come back and add some more fillets if we want to add some small fillets to smooth out some corners, or any of that geometry that we want to change. If we want to print out a small section of this and make sure that the camera interaction with that bump and that latch is okay, we can do that as well. But if we want to save out this individual body, the first thing I want to do is actually right click on this, and I'm going to say insert body into new part. Now typically when you do this, you'll save it out as a solid part file. So if I say OK, it brings it into a new part, and we can save it as a part file. Now, of course, there is some sort of link back to the original file. But the good thing here is you can also change the file type. So I can save this as an STL, and I know that it's only this individual body that we're dealing with here. We're not bringing any of that camera geometry in. We're not bringing the end of the cable in. We're only dealing with this single part that we want to 3D print. So there is a few things that you need to know when you save an STL. Now, STL is going to be the standard format you're going to save when you send this out to be 3D printed. Depending on the process and depending on the resolution of the printer you're using, you might have to tweak some of these values. Now, there are three options within SOLIDWORKS here. We have coarse, fine, and custom. Now, the tolerance for the deviation and the tolerance for the angle are going to determine basically how much of this curvature gets accurately represented. So you can see here with the coarse option, the angle tolerance is 30 degrees. That means it's going to make straight lines for all of the curvature, and you're going to have faceting that's going to be at a 30-degree angle between each of those lines. So this means that a part like this that we're dealing with that has a lot of curvature and it really needs to match the pocket or the area that it's going into, that means that it's going to have horrible resolution. If we go to the fine side of things, you can see that it puts it at 10 degrees. Now 10 degrees is going to be a standard value for some of the lower quality printers. I don't really want to say lower quality, but you're not dealing with $50, $60, $70,000 plus printers. You're dealing with $1,500, $2,000, you know, your Cube 3D printers, your MakerBots, things like that, desktop FDM type printers. Those printers are probably going to be limited to 10 degrees or above, and that's simply based on the resolution that they can hit with the equipment and how all the parts move. The custom setting allows you to manually change this. Now, if you're dealing with a high quality resolution printer, if you're dealing with SLA, SLS, even some of the higher quality FDMs, talk to whoever's printing this for you. If you guys have a printer, look up what the tolerances are that you can use. But if you have something that has a lot of curvature on it and it's really important that you keep that curvature, then you can crank this thing down to 3 degrees, 5 degrees, 7 degrees, whatever the printer will allow. And it's very important that you understand these values, the angle tolerances, because if you just save it out as coarse and you send it out, it will get printed like that and it'll come back and it'll look horrible if you have a lot of curvature. But on the flip side of that, if you save a file with 3 degrees or 5 degrees tolerance and the printer can't hit it, it might actually skip some geometry. You might get gaps. You might get areas where it's trying to hit it, but it really just misses. And when it lays down another trace, and then things just aren't going to match. And again, you're going to get a part that looks horrible and the quality is going to be really low. So make sure that you understand what process you're sending it to and what kind of tolerances. Any of the companies that are going to do these 3D prints for you are going to be able to give you some sort of standard settings. And you can always talk to them, ask them if they can do better, certain machines or whatever it is. There's also an option that says do not translate STL output into positive space. So I typically keep that option on, and this will keep the part located at whatever origin you have. In a lot of cases, you'll notice that if you actually translate into positive space, that your part will be located in positive X, Y, and Z in all cases. Now, in some cases, that's okay. In other cases, it's going to produce problems. So again, make sure you understand where these files are going, who's using them, what printer type, if you're using FDM, SLA, SLS, or whatever the process is going to be. Make sure you understand what it's looking for and what kind of tolerances you're getting. So once we say OK, we can save this out. We can say scan to demo, camera print file, and save it out as an STL. So it's going to go through, you're going to get a preview on the screen of all the different polygons, all the different meshes, the triangles that it's creating. And you'll notice that you get a pop-up here. It says 19,112 triangles, and then there's your file size. So you can see here in areas where we had a lot of curvature, especially inside the cable exit here. So you can see there's a lot of data inside there. Anywhere we have fillets, such as these corners, it's going to greatly increase the size. This back face, where it's not plain, it's got kind of funky curvature to it, you can see that we have a lot of small triangles in those areas as well. So once we say OK, you'll notice that this part file has not been saved. It's not saved as a SOLIDWORKS part. We simply saved it out as an STL, and you still have it open. You can do whatever you want to it. You can try to hack it up, make it lighter, do whatever you need, and not mess with the original file. Now, it is important to note that when you do the right click and save or insert into a new part, any changes you make to the original file, to this file, will trickle down to this file. Make sure that you understand that you make changes on the other file, it will affect this file if you save it out. It won't affect the STL file, but it will affect the part file. So as a last step, let's go ahead and open that STL file and take a look at it. When you open an STL file, you have some options. In most cases, you're going to open as a graphics body. With more simple STL files that don't have a lot of the curvature, that don't have all these triangles, you can oftentimes open them as a solid or a surface body and actually use that geometry. For this case, I know that it won't open unless it's a graphics body. So this means that we can't do anything with it really. We can't measure it, but we can take a look at it. And the reason this is important is sometimes, especially when you're dealing with parts like this that have a lot of curvature, sometimes when you save it out as an STL, you will get surface errors. You might notice that an entire face is missing, or there might be some extra geometry that you didn't intend to come in. So it's a good idea to take a close look at these files, rotate them around, especially areas that have great detail that really need to be accurate when it's printed. Make sure that it's all there. So it's a very important step in the printing process. You don't want to just save this out and send it off without inspecting your work. So open those STL files back up, make sure that you get what you want. Now, if we go back to that part, let's go ahead and save this again as an STL file. And we're going to go ahead and save it as a low-res version and modify our options to be a coarse 30 degree. So let's save that out. And you'll notice that we have many fewer triangles here. We have 3,120. So let's open this file up as well. So we're going to select STL and we're going to open the low-res version of it. Now, as we rotate this around, we'll zoom in. You'll notice on areas that have a lot of curvature, such as these fillets, that you can visibly see the faceting in this file. Now, the area where the camera is inserted in, you can visibly see the faceting. Now, what this means is if we zoom in here, the bore for the camera, you can see the faceting there. This can make it very hard for you to get high quality prints if you send something out like this that has 30 degrees as opposed to the file that had that 5 degree or that 10 degree number. There's a very drastic difference in the quality of these edges. So you can still see some faceting here, and you're always going to get that, but just the difference between 30 degrees and 10 degrees or 5 degrees can make a drastic difference in the result and the end product that you get printed. That completes the video series. Just a quick recap, we took a look at importing a mesh file, a .ply file, and we used that scan data, that mesh file, and we manipulated it with SOLIDWORKS ScanTo3D. We created a surface using the two different methods, the automatic and the guided creation, and then we took that guided creation surface and started designing our part. Now, it was important to make sure that we don't get stuck going down one path. We started a single path and we decided that going a little bit more complicated and doing more organic surfaces would be better in this case to help us locate the part. We created some solid geometry using the surfacing tools, added some features, and then we looked at the final product and options on how to save it out and what some of the different settings are with your STL files. So I hope you guys picked up a few things and enjoyed watching this series. As always, if you have any questions or comments, please email solidworksupport@mlc-cad.com, and we'll see you next time.